Now that we created our continuous integration workflow in the previous video, we'll get started on our continuous delivery pipeline now. So the first thing we'll do, as we've done before, is to create an on trigger based on push this time to the branches develop. Instead of a pull request, in case of our CI workflow, we're using push because we want this pipeline to be triggered when the pull request is merged to the develop branch. Optionally, you can also add this section where it detects the path from where the commits are detected. In case of our jobs, this time we'll keep only one job, as we want the steps of this workflow to run sequentially and have them depend on the other ones. So let's call this job build, push, deploy altogether. And in this job, we'll begin with creating our virtual environment in Ubuntu. And in our set of steps, we'll begin with checking out our repository in the virtual machine, and also configuring our AWS credentials as done before, and also to set up Terraform. And we'll also run the Terraform plan again, initialize our backend configuration with the prod state and run our Terraform plan again before we try to apply it. And finally, we'll run the apply step. So again, mind the indentation. Again, to repeat, we are setting the working directory to the infrastructure repository where we are running the Terraform code from. So in the Terraform apply step, we are also adding a condition to run this only when the TF plan step is successful. We are managing this by referencing to the TF plan ID here of the step and returning its outcome to compare it with the success value. If it fails, then naturally Terraform won't apply and it would trigger an error in your CI/CD pipeline and won't proceed ahead. Also for your Terraform apply, we'll be auto approving this as we cannot manually pass a yes value in a CI/CD workflow. In addition to this, we'll also be printing some output values of some of the resources that we are creating via Terraform, particularly for the ECR repository, the prediction stream, the model bucket, and the Lambda function. And for Terraform to be able to do this, we are going to create some output variables on these. So let's go to the infrastructure directories base level main file. And in here, we'll be creating these 4 output variables. So beginning with the Lambda function, which we are assigning the same name as the input to the Lambda function module. The next one becoming the model bucket. So for this, you equal module dot. Okay. Similarly for the prediction stream name and for your ECR repository, we are passing what we passed as the input value. This one. All right. And note the naming convention of these output variables, because this needs to be consistent with what we are passing as output here as well. At least this is how we have configured it here. Okay. And once this is ready, we will move on to the next step, which is the push section. Now, this entire part, as we explained in the first video of the CI/CD part, is like this is the defined infrastructure section. So let me just call it that. Define. The next part is the push section. Rather, the build and push section for the ECR images. And in this, we'd be creating a step to log into our ECR repository using an AWS action for the GitHub CI/CD workflow. So it basically takes in the credentials of whatever you've already set in your AWS configuration environment. The next one is the build step. So over here, we are building the Docker image to for our Lambda function. We are setting the working directory to the code directory where our Lambda function and Docker file are present. We will be also setting some environment variables here. So we'll be needing the ECR registry, ECR repository, and the image tag. For the ECR registry, we are going to output the unique registry URI for this account, which would be derived from the login ECR step. For the ECR repository, we are taking the output from the TF apply step, where we set the output variable for the ECR repository. And for the image tag, we'll be using latest just to simplify our exercises. Alternatively, you can also use a GitHub SHA ID or a hash ID or something similar to maintain the versions of your images. And this is more frequently done in case of blue-green deployment style. And the next one is next we build our Docker image with respect to the configuration we passed for our registry, repository, and image tag. And then we also push that here. And additionally, we'll also output the step to the image URI. One thing that I didn't cover is this is how you can set the output in your GitHub CI/CD workflows, where you can assign the field, the name of the field with the name tag, and the value is separated by 2 colons here. So this completes the build and push section. And let's move on to our deploy part where we are going to update our Lambda service and its configuration. Now, the first step in the deploy section is the get model artifacts step. So this is a replica of what we actually did in our demo video, the final demo video for our Terraform exercise. The little bit of a hack that we put in terms of copying the model artifacts from the dev to the prod bucket to mock our prod bucket environment in terms of assuming that it already has the artifacts from the training pipeline. And the second thing is to grab the run ID for our latest model version, assuming that it is actually grabbing it from a model registry like MLflow or DVC. So let's put those hacks in place. So at first, we will be setting our work directory. Secondly, we want to set our environment variables for the dev bucket where we are copying the artifacts from, and to the for the prod bucket which we are creating by Terraform. So we are grabbing the model bucket output from this step. And in the run section, we'll be copying the same steps that we ran in our deploy manual script, which is to query the run ID based on the latest partition retrieved from the descending order of the last modified timestamp, and also to copy over our model artifacts from bucket to bucket. So here you go. And naturally, we'll also be setting a variable for our run ID based on what we are extracting here. And finally, the next step is to update our Lambda. I think missed an implementation, so go. Okay. So let's start with setting up our environment where we need our Lambda function, the prediction stream name, the model bucket, and the run ID. This is the Lambda that we will be trying to update, and these are the 3 environment variables that we'll be passing to the service. And in the run part, we will be just copying over the variables that we need here. And we want to update our Lambda configuration with those variables. And in between these 2 steps, you can give this a try, but ideally it's best to keep a bit of a sleep timer between before the Lambda gets updated. So do note that we are creating the Terraform infrastructure in the same workflow as the place where we are updating the Lambda. in practice, generally, these are two separate workflows from two different repositories where your application code is stored differently in a different location from your base infrastructure code. So we want to wait for the Lambda to be created, to be bootstrapped and ready to be used. And it might, in the absence of this particular step, it might be possible that you come across an error where the resources in deadlock are not ready to perform any operation such as updating the configuration. So we are adding this particular step to wait until the state changes from in progress to something like ready. Okay. And this completes our continuous delivery workflow. And let's push this and give it a run. So because we made changes in our code directory also, this will also trigger the CI pipeline, which we would have to wait for until we can merge the pull request and create the deploy part. So this will take a bit of time on your end, but we'll just skip to the part where we are merging the pull request and seeing the operations of the deploy workflow. Okay. So currently we already have our pull request created from before, and it has okay. So now that the CI tests have completed running, let's merge this pull request to the develop branch. So go and push it here. Just make sure that this is the commits that we are pushing to is the develop branch, not the main one. From and this triggers our CED continuous delivery pipeline now. It will create all of this infrastructure on for our production environment. All right, so our TF plan is now created. And the new image is also pushed to the ECR registry. along with the model artifacts updated for our Lambda service. And it's all there. And it successfully finished the execution. So here we go, our production Lambda. Also remember that we, at least I destroyed the staging environment in the previous sections. So I hope you've done that too. And if not, then you should be able to see staging specific resources simultaneously existing here. There you go. In our state bucket, we are now having two TF state files, one for staging and one for production. And you can check for the other components also. You can give this a try just like you did with the staging environment by pushing a record into production resources and trying things out. Also note that we are repeating the step to build and push our Docker image for the Lambda service. Again, in this step, even though the initial version of the Docker image is packaged in your Terraform code, this is because we want to keep our application logic fresh, and regardless of any changes in the Terraform infrastructure, the application logic should be updated in a decoupled fashion through your CI/CD workflows. So congratulations, now you have both of your CI/CD workflows deployed in production. And just to recap, now we learned how to use GitHub Actions to create workflows that automatically tests a pull request, builds and pushes a Docker image, and deploys your updated service to production. We also saw that by creating specific YAML files in your GitHub repository, we can automatically kick off a series of automation steps. And now I hope this will give you more motivation to automate your tasks with GitHub Actions, such as orchestrating a continuous training pipeline, referenced as CT, to retrain your model and generate updated model artifacts in production, or to integrate your model registry such as MLflow or DVC to fetch the latest model version or experiment ID, and many more. Whatever you do, I would be open to discussion and help you out in the process. So enjoy this section, and yeah, see you again very soon.